Ever pondered why the world's most used construction material, concrete, still has its limitations? Even though concrete has been the backbone of construction for centuries, it isn't without its shortcomings. Firstly, let's talk about strength. Concrete is incredibly resistant to compression, but it struggles with tension. This means that under certain forces like bending, it can crack or even break. Then there's durability. Over time, harsh environmental conditions like freezing and thawing can cause the concrete to degrade and weaken. And let's not forget the environmental impact. The production of concrete is a major contributor to carbon emissions, posing a significant challenge for our planet. All these limitations not only affect the lifespan and safety of our buildings, but also drive up costs in the construction industry due to maintenance and repair. But what if there was a way to overcome these limitations? Enter nanomaterials. Nanomaterials, microscopic entities with the power to revolutionize the construction industry. These are not your regular materials. They are composed of particles that are a billionth of a meter in size. To give you a sense of scale, that's like comparing the size of a marble to the size of the Earth. These minuscule particles possess unique properties due to their size, surface area, and quantum effects. They are stronger, lighter, and more reactive than their bulk counterparts. Let's take a look at a few examples. Nano-Silica, Nano-Titania, and carbon nanotubes. Nano-Silica, a common ingredient in computer chips, can increase the strength and durability of concrete. Nano-Titania, on the other hand, has photocatalytic properties that can make concrete self-cleaning and air-purifying. Carbon nanotubes, the strongest and stiffest materials yet discovered, can significantly enhance the mechanical properties of concrete. Now imagine combining these nanomaterials with concrete. Nano-enhanced concrete, a futuristic construction material with the potential to redefine our built environment. Imagine a world where buildings, roads, and bridges are not just stronger and more durable, but also resistant to the harshest environmental conditions. This isn't just a dream, it could soon be our reality thanks to nano-enhanced concrete. Let's dive a bit deeper. Regular concrete, while reliable, has its limitations. It can crack under stress, deteriorate over time, and succumb to environmental factors like moisture and temperature changes. But when you infuse concrete with nanomaterials like Nano-Silica, Nano-Titania, and carbon nanotubes, you're not just mixing materials. You're engineering a revolution. Nano-enhanced concrete is a game changer. It's like giving concrete a superpower. The tiny, almost microscopic particles of these nanomaterials seep into the concrete, filling in the gaps at a molecular level. This not only makes the concrete stronger but also enhances its durability. The strength of nano-enhanced concrete is remarkable. It can withstand significantly higher pressures than regular concrete. This could mean taller, more ambitious buildings, longer-lasting roads and bridges that stand the test of time. But it's not just about strength. Nano-enhanced concrete is also incredibly durable. It resists wear and tear, holding its own against the ravages of time and the elements. This could lead to fewer repairs, lower maintenance costs, and a longer lifespan for our infrastructure. And let's not forget about resistance to environmental degradation. By resisting moisture absorption, temperature fluctuations, and even chemical corrosion, nano-enhanced concrete is set to redefine what we consider a harsh environment. Just picture it, a cityscape of towering skyscrapers, resilient roads, and enduring bridges, all built with nano-enhanced concrete. It's a vision of the future where our built environment isn't just stronger and more durable, but also more sustainable. Sounds impressive, right? But the journey to a nano-enhanced future isn't without its challenges. While the potential benefits of nano-enhanced concrete are immense, the path to its widespread adoption is filled with obstacles. Let's face it, every innovation comes with its set of challenges. And the same is true for nanomaterials in concrete. First, there's the issue of cost. While nanomaterials can enhance the properties of concrete, they also come with a heftier price tag. Nano-Silica, Nano-Titania, and carbon nanotubes are all more expensive than traditional concrete materials. This makes nano-enhanced concrete a more costly option, and could deter its adoption, particularly for large-scale infrastructure projects where budget constraints are often tight. Then, there's the challenge of production. Manufacturing nanomaterials is a complex process that requires high precision and advanced technology. Scaling up this process to produce enough nanomaterials for widespread use in concrete is a daunting task. It requires substantial investment in infrastructure, technology, and skilled labor. Lastly, we must consider potential health and environmental risks. Nanomaterials are so small that they can easily be inhaled or absorbed through the skin. There's still much we don't know about the long-term effects of exposure to these materials. Similarly, the environmental impact of nanomaterials is not fully understood. We need more research to ensure that the use of nanomaterials doesn't inadvertently harm our health or our planet. However, the potential benefits of nano-enhanced concrete may well outweigh these challenges. Despite the hurdles, the promise of stronger, more durable, and environmentally resistant concrete may be worth the effort. So, we've talked about the limitations of today's concrete, the potential of nanomaterials, and the benefits and challenges of nano-enhanced concrete. To recap, we've delved into the current constraints of conventional concrete. While it's served us well for centuries, it does have its shortcomings. It can crack, degrade over time, and is susceptible to environmental factors, all of which can compromise its integrity and longevity. Then we explored the amazing potential of nanomaterials such as Nano-Silica, Nano-Titania, and carbon nanotubes. These microscopic powerhouses can significantly enhance concrete's strength, durability, and resistance to environmental degradation. They can make concrete smarter, stronger, and more adaptable than ever before. We also touched on the exciting future of construction, where nano-enhanced concrete could revolutionize the way we build and maintain our infrastructures. Imagine skyscrapers, bridges, and highways engineered to last longer and withstand harsher conditions, all thanks to nanotechnology. But as we've highlighted, implementing these nanomaterials in concrete is not without its challenges. There are hurdles to overcome, including cost, scalability, and environmental impact. Ensuring these nanomaterials are safe and sustainable is as important as harnessing their potential. The future of construction may well be nano-enhanced, but as with all technological advancements, it's a journey filled with both promise and obstacles. Stay tuned to see how this exciting field develops.